Hello, YouTube. This is UMLs03. In the previous two lessons, we were taking a look at two topics called inheritance and polymorphism. And essentially, the idea here is that we can take a class and then we can essentially have another class that will extend the main class. So it will basically inherit all the functionality of the class that it's extending. And we saw an example of that. We created a person class, and we've been studying this person class for over 10 lessons now, ever since lesson 22. And we said that person has its own functionality. So it has getter and setter methods, and it has a toString method, which is basically a clean string representation of a person object. And we said if we want to have a class like student or doctor, those are pretty similar to person. So the only thing you really have to do is write these two lines in your class header. You write extends person. And then just like that, suddenly student gets all of person's methods. So student gets the get age, the get name, the set age, the set name, and the toString. From there, it's up to student either to just be okay with those methods, or student can go ahead and modify those methods. And we saw an example of that when we scrolled down and look at this toString method. We said in the previous video that we were going to take person's toString method, take the result of it, and concatenate another string if we were talking about a student, because a student is a more specific example of a person. And so a student has a GPA. And if we're printing a student, we wouldn't want to just know their name and their age, but it would be helpful to know their GPA as well. And then we also said that subclasses can have their own methods that don't belong at all to the superclass. So for example, study harder, you would never be able to call that on a person object. Okay, so study harder and get GPA, these are methods that belong strictly to the student subclass, and that's totally okay. And one of the things we said is in our discussion of polymorphism, we were looking at this person tester. And in the last video, we said that if you declare an object of as an instance of a superclass, but you initialize it as an instance of a subclass, then that object can only use the methods that were defined in the superclass. And then if the subclass modifies those methods, then the object will use the subclass's version. But any methods that were only in the subclass cannot be accessed by an object that's declared as an instance of the superclass. So that's essentially what we have going on here. And so all we have to do is this explicit data type conversion. So down here we said Dr. B equals doctor of A. And then suddenly we have access to the get hospital method, which A doesn't have access to, but B has access to, because B is actually a doctor, whereas A was technically registered as a person. And we said the same thing down here. So with a student, we had a similar example where we converted this person object to a student, and then we were allowed to call e.studyharder. But if you just call d.studyharder, we saw an issue with that because Java could not find a study harder method in the person class, and that's what happens. And so you're able to call the get GPA method after studying harder on this student object. And so that's why we saw 3.3 instead of 3.2 for this number, because 3.2 is what the default GPA was, but we called this method which increments the GPA by 0.1. We're going to continue talking about polymorphism and inheritance in this lesson, but we're going to do it in the context of abstraction. So there's a new topic that we need to consider, and it's called an abstract class. An abstract class is just like a superclass. The only difference is we're not allowed to initialize it. So basically a class that inherits or extends an abstract class needs to basically provide concrete definitions for any of the methods that were abstract in the abstract class. But we're going to be explaining that. But before we get into all of that, I wanted to bring up basically another type of keyword. So we've already talked a little bit about the difference between public and private. And we said that a public method can be accessed by classes other than the class in which it's defined. And a private method can only be accessed in the class in which it's defined. Think about subclasses. What if we wanted to have a type of variable or a type of method that could be accessible or viewable to all the subclasses, but to no other classes? That's called protected. So a protected variable is like halfway between a public and a private variable. It's public in the sense that other classes can technically access it, but it's private in the sense that those other classes that are accessing that variable need to be connected. They need to be connected to to the object. So essentially, if you have what I'm going to do is show you an example. So what I'm going to do is I'm going to say protected in X equals 3, and I'm going to make it a class variable. So you can see it comes right underneath these two instance variables here. So remember, we had the private string name, private int age. That's just the declaration of the two instance variables that goes at the top of the class. And then we have protected in X equals 3. So let's try figuring out what that does. Or actually, let's call it something else. So let's call it protected number. Okay, that's a long name for a variable, but I'm just going to call it protected number and show you how it works. So now, if I go ahead and come up with a main method in the person class, right? I'm right here in the person class, just underneath where this variable was declared and initialized. So if I go ahead and say something like protected number mod 2, it's totally able to handle that, right? So let's take a look at what the issue is here. So it says non-static variable. So basically, this is being referenced as a if you are going to have a variable that belongs to a class, you need to make it a static variable. So what you would do is you would say protected static int protected number. So the protected means that it can be accessed in this class in all subclasses. And a static variable just means that it belongs to the class rather than a particular instance, right? Like with name and age, those are instance variables because they pertain to an instance. But with this static, we're saying that this variable doesn't pertain to a particular person object. It just belongs to the person class as a whole. And so now if you go ahead and say system.out.println of protected number mod 2, we know that the remainder when you divide 3 by 2 is 1. So now if you go ahead and run the main method of the person class, you get the 1 there. And now what we could do is we could go ahead and try working with that variable in the main method of the student class, because I just want to show you the accessibility that a protected variable would have. So remember, public means it's accessible anywhere. Private means only in the class it was defined. And protected means only in the class it was defined or one of the subclasses. So now if you say system.out.println of protected number plus 2, there's no issue with that. I think what you could also do is go ahead and call person. So it's a variable that belongs to the person class. That's what we mean by static. We mean that it belongs to a class itself rather than a particular instance. So you could say person.protected number, or it would know what you're talking about if you just say protected number, because it's a protected variable, which means that it's accessible to the subclasses. But now let's go ahead and try using the protected number in the person tester class, because the person tester class certainly references the person class, but it's not a subclass of the person class. So presumably we would have an issue if we went ahead and tried printing the protected number here. It would say, well, I don't know what you mean by protected number. So doctor and student know what protected number is, but not person tester. And the same thing would work if you were talking about one of the methods. So if you made a method protected, the subclasses can get to it, but not other classes. So hopefully you can understand. And the only thing we have to do, if you want a class variable like that, you just need to define whether or not it's going to be public, private, or protected. So that's what you do first. And then you can go ahead and call it static. It's going to be a class variable. And then you can decide what data type it's going to be. Maybe it's a one-dimensional array of characters, and you could call it characters, and then you could go ahead and give it an initial value, right? So maybe it has a capital A, and then it has a space, and then another space, and then a period, or something like that. But that's totally legitimate, and then Java knows what you mean by that. There's another type of keyword that I wanted to go over in this video, and then we can finally start talking about abstract classes, and that's the word final. So if you put the word final in between the, I guess, the level of privacy and the type of variable that is, if you're talking about a static variable, you write static. If you're talking about an instance variable or instance method, you don't write instance, you just don't write anything. So, but if you want to basically come up with a class variable or some variable in a method that you don't want to allow changes to, you want its value to be fixed, you need to write final. So now what you could do is you could say final int number equals 200, okay? And then it would be able, and then that just means that number is not allowed to change its value. So you would be able to print that number, you'd be able to print the number plus 1, but you can't actually increment the number. So now if you say number plus plus, it already has an issue with that. It says you cannot assign a value to a final variable number. Okay, so whether you're talking about this, because right now this is a method variable. So right now the number integer is accessible to the main method, but if you want it to be accessible to all classes, you would basically initialize it as a static variable at the top of your class. So you would say public or private. Do you want other classes to be able to access it or not? But you would say public static final int number, and then you call it something else, number 2 equals 300, and then all methods in this class or outside of this class would be able to use number 2, but none of them would be able to change it. So hopefully that kind of gives you a little bit more of an idea of what we mean by that. With an abstract class, basically, we're not allowed to instantiate an abstract class. An abstract class basically provides a blueprint for other classes. So basically what we're going to do is we're going to create an occupation class. Okay, so you can go to new class and you're going to call it occupation. But we're going to make it an abstract class. And the way that you identify that in Java is by writing abstract in the class header up here. So instead of just public class occupation, you're going to write public abstract class occupation. And so this class is going to be a blueprint. It's going to basically be a framework or basically a model for other classes that inherit this class to like go off of or define, but you could not instantiate an occupation object. So let me show you what I mean by that. In an abstract class, we can have both concrete methods and abstract methods. A concrete method is a method that has a formal definition right there. So if you say, for example, public static, you could say public void work. Okay, so what this is going to do is I'm going to say that any class that extends occupation, that extends this subclass, is going to have access to this method. So it's just like the subclass that we were doing, right? It's just like we said, okay, if student extends person, then student gets person's get name method. And so we're just basically in the superclass right now, but we have to remember that even though this superclass is going to have concrete methods, even though it can supply methods that are available to us in the subclasses of the abstract class, we're only able to instantiate instances of the subclass. You can't instantiate the abstract class. So let me show you what I mean by that. So we're just going to have a very simple void method called work. It accepts no inputs, and it's going to apply to an instance of a class, which is why I don't have the word static here. But what we're going to do is we're going to say, crap, I have to work today. So this is an example of a concrete method, and any class that extends occupation will be able to call the work method on an instance of that subclass, and that subclass will be able to print, crap, I have to work today. So let me show you what I mean by that. So this is an example of a concrete method. So it's basically a formally defined method, has a definition here. So has instructions for what work does, okay? But in an abstract class, you don't have to have full definitions for all the methods. An abstract class is just a blueprint. So what you can do is you can have concrete methods that define functionality like we do here with work, but you can also have abstract methods, and those are basically just headers with method names. And then every class that inherits occupation, that's a subclass of this abstract class, must provide definitions for the abstract methods of this abstract class. So let me show you what I mean by that. What I'm going to do is I'm going to say public abstract int get salary. And so you're not even going to define it here. You're simply going to write the method header. What this does is it's an abstract method. So it has no definition in the abstract class, but this line of code mandates that any class that extends occupation, so is a subclass of occupation, must provide a definition for get salary. Okay, so if you were, it depends on what subclass you were talking about, right? If you were talking about a teacher, maybe their get salary method would be defined a little differently than if you were talking about a lawyer or a doctor. So that's an example of an abstract method, and we're going to provide a formal definition for it coming up here. So then essentially you're also going to have a complain method. So public abstract void complain, but there's going to be no definition for that here. we're going to have to basically build a subclass that will provide definitions for these two methods. The concrete is fine. This work method is fine. The subclasses are going to get that, but the subclasses on their own will need to provide definitions of the get salary method. You're just going to have to figure out an integer to return, and a complain method, which is not going to return anything, but we'll have to specify what it ends up doing. So now we have that abstract class there, and you can see the abstract header on it. And now what we're going to do is we're going to create a new class. So this is going to be a subclass of our abstract class. And we're going to call it waiter. So we're going to say waiter is a subclass of occupation. So you're going to say public class waiter extends occupation, and then you can go ahead and delete this code right here. And then we could go ahead and figure out what's going to happen here. So you could have a default constructor, but for this particular example, I'm not going to worry so much about assigning values to instance variables. So we could just have a pretty simple default constructor. So this would be just a standard default constructor. There are no instance variables to assign, so not much work here. But now what you can do is you're going to need to go ahead and provide definitions for those two methods that we left abstract in the abstract class. Because now if we go ahead and press compile, you would need to, oh, Walter, that's an issue, right? So waiter, right? And now it says public class, there's an issue. Waiter is not abstract and does not override abstract method. Complain, so that it doesn't provide a definition for complain, and we need to do that. So what we're going to do is we're going to say public void complain. So now we're actually providing a method for the method that was listed as abstract in the previous, in the occupation. Remember, occupation, there's no definition for complain, so it's up to any subclasses. They need to go ahead and redefine it, or define it for the first time. So what you would do for a waiter is you would say something like crap, more customers, okay? And you're still not done, because now if you try compiling it, it throws another issue at you. It says you didn't define the get salary method. So now all you need to do is provide a definition for the get salary method. So what you would do is you would say something like return 45,000. And now if you go ahead and compile it, so the waiter now has definitions of complain and get salary, so it's able to extend this class. And now this is a full architecture. So now what you could do is you could do a tester class. So you could do something like occupation tester, and we can come see the functionality of these waiter methods. And I'm realizing this video is already getting pretty long, so this is just basically an introduction to abstraction. But what we're going to do is you could say public static void main string args, and now you can test this waiter thing. So you could say waiter w equals new waiter, right? It would just be calling a default constructor. And so we said nothing was really happening in this default constructor. In fact, you don't even have to write this constructor, because we said it a few videos ago that every class gets a blank default constructor by default. So the only reason you'd have to write a default constructor is if you want to provide default values, is if you want something to happen. And we saw that with the person class, right? We actually had to assign instance variables if the user didn't pass in anything. But for waiter, we're not really caring about their name or age or anything. We just want to demonstrate the functionality of these methods. So now that we have the waiter, we can go ahead and call one of these instance methods on the waiter object. So we could call complain, we could call get salary, or we could call the work method. So now what we're going to go ahead and do is we could try all of those. So we could say w.work. So this is a method that was defined concretely in occupation and inherited by waiter. Okay, and that's totally legitimate. So basically the point is that abstract classes can have concrete methods, but they also can have abstract methods. And that's what distinguishes them from regular classes, is the fact that they can have abstract methods, which must be defined in any subclasses that inherit the abstract class. So now we have w.work, and then we have w.complain, and then we could say system.out.println of w.getSalary, and we should see that all these methods function as intended. So now if we're going to go ahead and run the main method of the occupation tester class, and then we have those three things, right? So this was the definition that the occupation class provided for work. And then these two methods, occupation didn't give us definitions of them. So it was up to the abstract class to provide formal definitions for them. And the abstract class must provide a formal definition for every single abstract method in the abstract class. So that took a little bit more time than I wanted it to, but in the next video, we're going to continue talking about abstract classes, and we're going to continue our discussion to think about interfaces, which are like abstract classes, except they cannot have concrete methods. So that's enough for now. I'll see you in the next video. From UMills03, thanks for watching, and please subscribe.